Welcome to episode 209 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going today?
I'm all right, Rob. How are you doing?
I'm doing good. Had a date night with my wife last night. We went axe throwing, which is something we've never done before. It was quite fun.
I have never tried that either.
Do
Did
they
you go to a
have axe throwing
special?
in your area?
Well, I mean, at the Renaissance Festival, it's definitely something you can do.
Oh, okay. No, they have like a bar in Durham. I think a different one in Raleigh. And we went to the Durham one. It was pretty good.
I actually
Fun.
did do a little bit of research to see if I were to do axe throwing in my backyard, is that illegal inside city limits? And it
Hmm.
does seem that there is the good possibility that it would be considered illegal. Like if that axe went astray and someone got hurt, I mean, like, you know, akin to
Yeah.
using a deadly weapon in your property, basically.
Sure. I mean, what if you have it like fenced off or something like that? How much
Yeah,
research did you look into this?
I don't remember. I think I gave up after like an hour or something, and I don't know. It's easy enough to just drive into like national forest or, public lands where you could do something like that anyhow with no problem. In the
Sure.
US, because we have lots of public lands.
This is true. Well, I'd recommend you trying it. It's fun.
Okay. Does that sound like fun?
Yeah. At the top of every episode, I like to read a piece of feedback, though. I'm going to say that again. At the top of every episode, I like to read a piece of feedback. This week, we got a tweet from Barney Deller saying, I really enjoyed the latest CPP cast with Claire McRae. I'm particularly pleased to see testing finally starting to become a normal part of C++ culture. And yeah, I certainly agree. And I kind of wonder about that statement. Like, is C++ testing not as widespread compared to other programming languages and their, culture around testing?
I think people who test, and it doesn't matter what programming language you're in. That is my impression as a teacher talking to people who are moving from other languages to C++. But there are definitely some languages that have always had like unit test built into the language core
Mm.
feature. And I think we're kind of, reaching the point where it is more and more normal in C++. We're somewhere in the middle ground, in my opinion.
Okay. I hadn't heard of that about testing being kind of built in as a language feature. What languages have that?
Well, there's stuff that makes it really easier, right? Like maybe I'm getting some stuff wrong here, but like in Unit with the .NET frameworks is
Hmm.
like really easy to use because it can be easily integrated in with the runtime, the CLR, and
Sure.
JUnit with Java similarly. Now, those aren't core language features, it's true, but they are things that are really, really easy to work with anyhow.
Yeah. Well, yeah, I definitely think it's a good thing that we should all be doing more testing. And yeah, it was great talking with Claire last week about approval tests because that was completely new to me. I believe it was new to you as well, right, Jason?
Yeah, I totally learned a lot, and I wish I could have gone back in time and shared that with the class that I had just had before that talk. And yeah, I actually had a discussion with my last class after that talk about the kind of tests that they're doing, and it seems that they're basically already doing something like approval tests there.
Okay. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes and subscribe on YouTube. Joining us today is Matt Butler. Matt is a security researcher who has been using C++ professionally since 1990. He has spent the past 3 decades as a systems architect and software engineer developing systems for network security, law enforcement, and national defense. He primarily works in signals intelligence and security on platforms ranging from embedded microcontrollers to FPGAs to large-scale real-time platforms. He's on the staff of both CppCon and C++ Now, as well as a member of the C++ Standards Committee. He spends most of his time in EWG, SG12, SG14, and now SG21, the new contracts group, and he's also a member of WG23, which is Programming Language Vulnerabilities. He prefers the role of predator when dealing with hackers and lives in the Rocky Mountains with his wife and daughter. Matt, welcome to the show.
Hey guys, thanks for having me on. I'm happy to be here.
Matt, I have to take issue with your bio here because it says you've been programming professionally in C++ since 1990, but as we all know, C++ was first released in 1998.
Um, the versions we have now, yeah, but there were one-off versions that you had earlier than that. But yeah, you're right. What we have now is definitely a 1998.
Yeah,
But
I'm
as
just
far
giving you
as
a hard time, of course.
as far as professionally programming, yeah, it's been since 1990.
So you must have had some serious growing pains because if you were 1990, you didn't have namespaces. You didn't have DSTL. You didn't have necessarily, you had pieces of these things maybe.
Yeah, no, it was the Wild West back then. That was I started out in college and it was all C. So when this language came out and I bought this book on C++, there was sort of this, I have no idea what this means and how this works. And so it took me about a week of reading and rereading this book and going through the examples to it finally clicking what object-oriented programming was all about.
Wow.
So it's, and ever since then I was hooked because it made so much sense at that point.
So, and just out of curiosity, do you remember what that book was?
I don't. And every time I bring this up or say this to somebody, I always tell myself I'm going to go back and look and find out what that book is. But it was 30 years ago. I mean, it was a long time.
Every now and then I go to, Goodwill or something, and I go trolling for old C++ books just to see if I can find something like really old. And I've been successful once and didn't buy the book, and I should have. But anyhow.
Well, I definitely prefer the modern versions of C++, so I'm happy with the new books.
Yeah, for me, it would be an exploration of if the stuff that they were teaching then was even bad practice then on the compilers back then, which I think in many cases it was. Like empty destructors has always been a bad idea. If you didn't have a reason to declare that destructor virtual or something, just having an empty destructor, it's always been a bad idea. I guess in full disclosure, I should mention Matt is also a member of my C++ meetup, although at this point I don't know if he's actually attending it more often than I am with my current travel schedule.
I was there last time.
And I was not able to attend, yes.
Okay, well, Matt, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking about, your background as a security researcher and the talk you'll be giving at CppCon, okay?
Okay, sounds good.
Cool. So this first one is a bit of C++ committee drama unfolding on Reddit. We spent a decent amount of time last week, or I guess 2 weeks ago, talking about contracts being removed from C++ 20 at the Cologne meeting. And I guess one of the authors of the original contracts paper wrote this long post on Reddit CPP, what happened to C++ 20 contracts, and basically complaining that it wasn't removed for a technical reason. And I'm definitely interested in hearing your take on this, Matt, since you're now a member of this new contract study group.
Yeah, so we had our first meeting this morning for SG21, which is sort of a kickoff meeting for before there wasn't a study group that handled contracts. It was pretty clear going into Cologne just by looking at the reflector that there was quite a bit of back and forth, and typically when you're this close to a release, you're not wanting to put in any kind of design changes. So a lot of the conversation was about, are the changes that people are proposing, are they design changes, or are they just wording changes to try and make things more clear or to tighten up on the feature itself? Monday when we went in, it became clear that, the first vote we took was, do we even want to consider these? And I voted yes, because I think you should consider things even up to the last minute. I actually did have some technical concerns about contracts. We can talk about that here in a little bit, mainly involving security and safety. Then it went on to these were voted in, and I think that sort of at the end of Monday sort of was the end of contracts coming out in C++ 20, because there was enough contention on both sides of, is this really what we want to do? Do we feel comfortable with what we're putting out there? By Wednesday, there was a proposal on the table to remove contracts altogether. I voted against that because while I wasn't happy with the current implementation, I do think that there's value in going ahead unless you can come up with absolute stop ship bugs in a feature. Go ahead and put it out and let's get some experience with it. I think that was probably the most compelling reason to put it out there. And then eventually in the end, the vote went strongly the other way to pull it out. And I can understand that there are, there's strong emotions on both sides. And that sometimes happened. We saw that with several other features that that have had to be removed from a standard just before they were due to go out, and then they came back stronger. So that's what I'm thinking we're going to have here is we're going to come back with a much better feature that will be much more useful to the everyday developers. And one of the places we're starting now is we're building all of the use cases as to what do we want contracts to cover, which use cases fit into a contracts mold. So while it's probably not the ending everybody wanted, I think we're trying to find the right path through and get a really strong feature the same way we have with concepts.
So at the moment, are you looking at starting from scratch or looking at starting from where it was last left off?
So right now what we're looking at doing is taking the use cases. I don't think there was ever really a consistent, a broad agreement on what the use cases are that contracts should be able to handle. So right now we're looking at generating all those use cases, going through refining them, and then coming out with a set that says, okay, these are the use cases where we feel contracts apply. And then take those use cases, go back and look at the various proposals and see how they match up against those proposals. Technically, we sort of have a blank slate at this point, but I think we'd all rather take advantage of the last 5 years of learning and understanding when it came to contracts and see what we can bring forward into the future with us. So that's where we are right now, and we're working on that for the next several months.
Now,
Okay.
I'm not going to ask you to specifically comment on some of these things in here because I know there's the code of conduct for the members of the committee and commenting on who said what about what thing. I do, well, the actual Reddit article itself is, I guess, strongly worded in some places, implying that there were people who set out to, sabotage the proposal from the beginning. And that there was originally 2012 and 2014, and it has this really long history. And if you read the comments, which I read almost all of them, it's all people that we know on this discussion. It's all people who are friends of CppCast who have been on here before. And I think for people who are just kind of interested in the human side of being on the committee, it's just a reminder that there's humans that work on this. It's not automatons who work on the committee, and there's a lot of humanity involved in the process, it seems.
Yeah, absolutely. And even if there wasn't a code of conduct, it's not really fair to quote people who aren't there to sort of say, hey, no, that's not really what I said or what I meant.
Right.
So, this is a very human story if you were to write about what went on in the back end. And sort of as a new member of the committee and sort of not having been involved in this all the way, it was what I was expecting, and it wasn't what I was expecting. By what was going on in the reflector, I sort of understood there was going to be a lot of contention, and we were going to have a hard time getting consensus. But I will tell you that there are some people who really, in this drama, as you put it, that really stood up and I think made a huge difference. And they I will name. So Herb, I think, helped get the process through with a minimum amount of collateral damage. Villy, I think, did a fantastic job. He does a fantastic job just running the group because you can be dealing with things in there. They're very contentious, and you do need that strong person who can sort of keep good order and discipline. Michael Wong came in on Wednesday night and was helping to see if there was a path through it to where we could maybe find that we had common ground, which is what we could go forward with. I wasn't in the room at the time because I'm not part of either proposal sets, but from what I understand, he put on a master's class in negotiations, and both sides said that. So you definitely had people that were sort of containing this, and finally in the end, nobody likes to see 5 years worth of work have to sort of come to a stop. You do want to have that Hollywood ending where it goes out and people use it, and it's great. But as I said, even I had some technical concerns over it. I just didn't think at this point that there was a compelling reason to stop it. But other people felt differently. So but yeah, there are strong emotions, and over time, hopefully those will begin to abate. I certainly can understand Nathan's position because he's been at this for a very long time.
Yeah, it sounds like I didn't realize that this person had been involved in it for 5 years or whatever. I guess that was before we started the podcast.
Yeah.
Ish, or about the same time.
About the same time.
Yeah, and we
Okay.
saw the same thing with concepts because it was something that had to be, they thought they were ready and then they didn't have consensus. They had to pull it out and they came back with something that I think the guys talked about last week that I think they're happy with, which is really what you're looking for. You're looking for people to come out and say, yeah, this is exactly what we think it needs. We're 95% of the way there.
Yeah, I certainly hope this committee group that you're a member of does a good job, and we are much happier. The whole committee is happier with contracts that we get, hopefully in 3 years, but we'll see what happens. Next article we have is Fixing C++ with Epochs, and this is from Vittorio Romeo, who we had on the show a very long time ago.
Long time ago.
Yeah, and he's putting forth this idea inspired by Rust editions that he's saying is now possible when we have modules to be able to basically have like libraries opt in to use a certain version of C++ and kind of make the ability of the ISO committee to introduce breaking changes more easy, more doable. I thought it was an interesting idea.
Yeah.
Yeah.
Yeah, there's a lot to like in this in his piece. At the end, he said, he'd be prepared to, he'd be willing to do a committee proposal. And yeah, I will go ahead and channel Herb Sutter. We look forward to your proposal. I think it's a great idea, but the details are the place where we tend to get stuck on things. So I would love to see that because I think that's one of the problems we run into is, well, how do you deprecate this? We're going through that with volatile. We're deprecating parts of volatile, adding things. So it does become a very complicated process to be able to come up with the next generation of the standard where you've got things that are moving in and out. So I'd love to see it.
I honestly like... and the particular things that he wants to do, replace initializer list with something that allows moves. Yeah, I'm on board with that, but whatever. Like I've given an entire hour and a half talk about how initializer lists are broken because we can't move from them. So I get that. Remove type def, be able to introduce await, and all of those. I'm like, yeah, that's all good. But then when he gets down to the more drastic changes that we could consider, const by default. And you have to opt into mutable. No discard by default, and you have to opt in with discardable. Make explicit the default, and you have to opt in with implicit. I am on board with all of those. I want that like yesterday, but those are also all things that we can do with static analysis. We do it right now. We can warn you if things are not no discard and could be, or things that are currently implicit and could be marked explicit, that kind of thing too. But I don't know.
And I should mention one of the things he's proposing in this is to be able to script going from one version to another or one epoch to another. So if you have something marked, no discard, to be able to just take that out because the default would become no discard, something like that, right?
Right.
Well, and that's where the details become important because I can see some of the things you just listed off, mainly at the end, being a little controversial. So it's that's where you get the details. That's why you need the proposal.
Yeah.
Okay, and then the last thing, CppCon is coming up. We've been talking about it a little bit more lately, and we just wanted to point out that if you're attending CppCon, they're now offering childcare if you're going to be traveling to the conference with your kids.
Yeah, the only problem is that the child care facility they're using is about 20 minutes away from the actual Gaylord. And there's a limited number of child places available. So if you're interested at all, make sure you go ahead and sign up for it. Make sure you utilize this. We want to encourage the conference to make this thing available next year as well, and perhaps make it more convenient if at all possible. Although I don't think the Gaylord has childcare facilities on site, so I don't know how much more convenient it could be. I know people who have seen pictures of the Gaylord immediately say it's in the middle of nowhere. And I've gone on record of already saying this. I just want to clarify. It's not in the middle of nowhere. It's just on the edge of nowhere. It is. You've been there, Matt. Right?
Yeah, that steep drop off is the edge of town. So yeah, it's. But if you've ever wanted to go to a one of a kind conference center to go to CppCon, this is it. This is like a playground. It's a fantastic venue.
It is absolutely beautiful, and there's giant, indescribably large picture windows that face right at. Actually, where do they face? Is that Long's Peak they're facing at? Anyhow, one of the peaks, and it's amazing.
Yeah.
Okay. Well, Matt, do you want to start off by telling us a little bit more about how you got involved in C++?
Well, when I was in college, it was all C, and you used Pascal and a bunch of other Lisp, and there comes a point where you're looking for something that's a little stronger when you're creating large code bases. And one of the first jobs I had outside of college was creating a system that allowed you to do bank failure analysis, and that requires a lot of math and a lot of moving parts, and C++ became a much better choice than trying to do it in C or Fortran. Fortran is very good at numerical processing, but back in the day, they didn't have orientation like they have now. So I found C++, and it was like, this is perfect. And I did what everybody else did when they first started with C++, is they started building these really deep hierarchies of objects. So you had these inheritance hierarchies that were miles tall, and then you quickly found out after having to maintain the code for a couple of years that was not a smart idea. The flat hierarchy works a bit better than these mountains of inheritance classes.
What does bank failure analysis mean?
So one of the problems we have with banks is they generate a lot of numbers. So there's a lot of metrics like their income and earnings and things like that. But the problem is how do you, and they have a lot of, so there's probably about 200 different things that a bank has to report to the Fed. It has to do with their health. So the problem becomes, how do you look at that data and draw any conclusions as to which banks are close to failing and which banks are really safe? Because if you just look at this minefield of data, there's no way to really tell which banks are having that problem. And this was right after the S&L crisis, where you had a lot of zombie institutions which looked really good on paper, but the minute that the interest rates flipped on them, they suddenly started failing left and right. So the Fed was really concerned about being able to look at the data and make some, because they had scarce resources, make some determinations about which banks they would actually go and audit just based on their numbers. So the bank failure analysis was really a way of going and looking at those numbers and finding, believe it or not, we used earthquake analysis for it, which was sort of strange, but it worked beautifully. I mean, we could, we had a really high success rate of being able to predict which banks 6, 12, and 18 months out were going to find themselves in trouble.
By looking for tremors?
Exactly. That's what you're really looking for, is you're looking for little things that are sort of hidden and things that aren't particularly obvious. But if you let the numerical analysis do its work, you find that that it will spot things that you don't normally see. And that's how I got into signals intelligence, is because you're really looking for the pieces of the signal that tell you something but are sort of lost in the noise of the background.
All right, so I'm going to go ahead and ask this, although it kind of sounds like you already answered it. How then did that C++ with bank failure analysis move into your interest in security?
Actually, that had, believe it or not, that had nothing to do with it. I went to, as soon as I got out, that was how I put myself through graduate school. And then when I got out of graduate school, back then it was called information systems, so it was an IS shop. And I worked there for a few years, did C++, several other languages, but then my next stop after that was a company that did defense work. And so in order to be able to work in that, you have to have a clearance, and suddenly everything is about security. And if you're working in a SCIF, which is a classified facility, there's all these processes you have to go through, and then of course they have to do this massive background, going back to birth to make sure that you're okay. And it was really there in living in sort of that where you're developing systems that now become targets for people looking to get in. You know, if you go back and look at the Cuckoo's Egg, that was sort of like even back in the war games era where you had a hacker from Russia trying to use all of the Berkeley computers to jump off into all of the military sites to be able to gather classified information and bring it back. We were really naive at that time about security. And at that time, the only people who really got hit by any kind of intrusions were military facilities, or later on it would wind up being their contractors, because people realized that they had weaker security than the military sites did. So that was where it began, and I would work, the next job after that would be in network security, where I was writing software that was specifically designed to defend networks from attacks. And then after that would be another cleared capacity where in one case they had no network when I walked in. They just had a bunch of machines in a work group. So I put in a domain controller, but my IT budget was exactly zero. So there was no parameters, no perimeter security or anything. And we got hacked by Russia and China in the same month, and I was the one who had to call the FBI. And so that was sort of the way. That's sort of, I had to really just in both cases sort of learn while under fire.
Wow. It sounds like a bad week at work if your job involves calling the FBI.
Yeah, they were very understanding the first time. The second time, not so much. And then they wanted to, they wanted to come and help us, which I was, I was defenseless to protect our network because I had nothing that I could use. My boss at the time freaked out when I said, oh yeah, the FBI will be here tomorrow. They want to talk about our network security, and he absolutely lost it. We are not having the FBI in here. It's like, well, you've already had Russia and China, so could the American government
why not the
US? Yes. So most of where I got into security was really sort of being on the receiving end of the inbound ordinance. And after a while, you realize, no, there's a better way to do the things we're doing. And so many of the things we do are just self-inflicted wounds because people don't really understand that security is not that difficult to understand as a concept. You just have to have it in the back of your mind when you're either building a system or writing code.
So let's go into more of writing code and how you can do that with security in mind. What are some of the topics you talk about with C++ and security?
So one of the things that I read that Twitter comment that you talked about at the top of the show. I think testing sort of becomes, it depends on your value proposition. We, as engineers, have a tendency to be very focused on designing and building things, and then we test it and we're happy with it, and we tend to test just the happy path. We don't tend to think about software in terms of, and it doesn't have to be someone trying to exploit your code. It could just be somebody accidentally using your code incorrectly. So you're building a library, you've got an application, and they do something you don't think that you didn't consider that they would normally do. So I learned a long time ago, just from being on the front lines of this, that an excellent QA organization will save you every single time because they will find the things you don't think about. They're experts at doing that. So I really appreciate the fact that there is a value proposition, and I see this a lot in C++, is that we're so focused on other things we don't think about testing. And I appreciate the fact that we've got people like Phil Nasher showing us how to do unit tests. One of the things I talk about in my class coming up at CppCon, the entire second day is nothing about testing, nothing but testing strategies for how do I take my code that I've got this wonderfully designed piece of code, now how do I go break it? But how do I break it in a controlled manner so that I know I've checked all those corner cases? And so we start with things like threat hunting, which is or threat modeling of a system, which is a way of looking for attack surfaces and attack vectors. But it actually also has a lot to do with how well is your system designed. When I go through this with a team, I'll hear comments like, oh, I didn't know that's how that worked. Or why are we holding that data? We're not actually using it anymore. So you go through this analysis of your architecture, and people will find that there are things in there, especially as architectures evolve over time, there are things that sort of get lost to antiquity. I just had a case where I found a feature that had a major security vulnerability in it that had been put into a product over a decade ago, and nobody knew it was there. It was listed in the documentation in sort of an orthogonal way, but until I looked at the code and I was like, what are they doing here? And that's where you get into some of these testing strategies and looking at your architecture. Then after that, the next step you want to do is things like we've talked about static analysis, and that's where contracts is going to help. We have dynamic analysis where we're looking at looking for undefined behavior. You're looking for thread problems. So you've got sanitizers that you can run against operational code, but in order to have those work correctly, you have to have a really good test set to make sure you're catching all those corner cases. You've got as much coverage over your code as you possibly can. And then, of course, you got things like fuzz testing and penetration testing, which is actually really the fun part. I'll have to admit, in all these years, I much more prefer playing offense than defense because it's just really a lot of fun to break.
So we've done a backdoor introduction to your class. Why don't you go ahead and actually tell us the name of the class, when it is, that kind of thing.
Okay, so the class is, in fact, it's at the same time Jason's teaching his class. No, yeah. It's called Exploiting Modern C++. And I've had some people come up and say, well, are you going to show us how to exploit modern C++? I says, yes, sort of. What I'm really going to teach you is how do you go and do a code review to find the deeper bugs? I mean, we do, I think as an industry, a somewhat poor job, at least in the companies that I've been involved with, of doing code reviews that are something more than variable names and line lengths. If something's really obviously wrong, we'll catch it, but what we're really looking for is catching those deep bugs that maybe are not quite so obvious. Like, one of the first things I teach people is you go in, the first thing I look for is where are you touching memory? Because you're almost always going to get that wrong. That's where you have off I1, buffer overflows, code pointer exploits. These are, and you just sort of over years begin to sort of pick up the sort of how code gets written and how these mistakes get put in. So exploiting modern C++ is not about teaching you how to be a hacker. What it is it's about teaching you how to write software that is correct, that is well-structured and well-architected. Give you testing strategies on how to test your code to make sure it's not going to fail in the field. Whether it's a hacker or somebody else that makes it fail, we all want to produce code that is going to stand up and do everything that we need it to do, and we have very few bugs going out the door. And so these are the strategies from an end-to-end, from architecture to release, that we're going to be talking about in this class.
So it's a 2-day post-conference class.
It is a 2-day post-conference class.
And who is who should take this class? Who's the
target audience?
Yeah.
Well, it does not have to be anybody who has even an interest in security. I mean, the security is sort of the aspect that I come at it from. But if you have any interest in producing well-constructed code that's been thoroughly tested, that going out the door, you've done a really great job on code review, so you've caught the majority of bugs there. Now you want to know how to use static analyzers. What are their strengths? What are their weaknesses? What kind of dynamic analyzers are out there that you can use? How do you set up a test plan to make sure that what you're doing in those dynamic analyzers is going to get those bugs that are deeper than the code reviews are going to find? So it's really for anybody that wants to produce high-quality code going out the door. Whether you're worried about hackers or not, this is really about writing code that withstands sort of living in the world where there are hackers, but there are also users that will do things with your products and your libraries that you weren't expecting.
So if you want correct code, you should take your class.
If you want correct, well-tested, hardened code that can withstand the punishment of the world that you're going to release it out into, yeah, this is a great class to take.
All right.
Okay. In addition to your class, you're also giving a talk at CppCon this year?
Yes, it's called If You Can't Open It, You Don't Own It. It's going to be a little bit different than the talk that I gave at C++ Now. I'm taking 4 what I think are legitimately called super hacks involving hardware. So we all know about foreshadow and a lot of the side channel attacks that we have seen.
We all know about
for a moment.
foreshadow?
Do not know about foreshadow.
Okay, so it's a derivative of meltdown and.
Okay,
so,
we do know about Meltdown Inspector, yes.
The Inspector. So these are all side channel attacks, but hardware is particularly vulnerable to side channel attacks because it emits a lot of things. And so what I do in that example is I take a side channel attack and say, okay, this is how you would do this against hardware. How does this apply to your software? And then we're going to begin looking at C++20 because it's coming out the door next year. What are the things that are in C++20 or in 17 or some of the other revisions that can help either help you or hurt you when it comes to security in your products? And we'll deal with other things like roots of trust, which is, we have sort of this implicit trust relationship. Hardware is specifically vulnerable to that, but software also has that as well. And we'll look at how these things begin to, the lessons we can learn in software, specifically C++, and then how the new language features coming out are, or the ones that we're considering for the future releases can help us in dealing with some of these vulnerabilities that we have. And it's no small irony that, Capital One just now became the poster child for the worst hack in the world, and that was an oversight, and that's the thing that I always teach students. Everybody will ask me, is C++ a safe language? And my answer is yes, if you know how to use it. But in reality, it is not the big things that get us. It's not your failure to do template metaprogramming correctly. It's not your failure to whether this constructor had an implicit conversion. It's those little things where we don't validate data. We forget that the buffer is really only so wide, and we put more data in that can fit there. We don't check the values coming in before we put them into a strongly typed enumerations were created in order to help us deal with the fact that you could have undefined behavior with just putting a value too large for an enumeration in there. So there's all these little small things that we do that sort of become the gotchas. And if you go back and look at Equifax, you go back and look at what happened with Capital One last week, or it's been a couple of months, they just announced it. It's those little small things that wind up burning us. It's not the language has a massive vulnerability in it, we need to fix the language kind of thing.
So if you can give us a sneak peek, you said you'll be covering some of the C++20 things. Is the language getting better or worse from a security perspective?
So one of my biggest concerns about contracts was where contracts are really a statement about what should be true. But in the software, the problem is you live in a world where almost nothing is true. Most of what you will get is exactly what you don't expect. And in contracts, one of the features of the current contracts was, what happens when a contract fails? Well, it calls a handler, and then it calls terminate. That right there is just a DOS attack waiting to happen, because it really doesn't matter how deep in your code it is, as long as I can trigger that by fuzzing your interfaces, then I know that I've taken your software down. I just keep doing that over and over and over again. Now that's a denial of service. Denial of service attacks usually tend to be masks for other things that are going on in the environment, because you're focused on why is this crashing. The next step in that, though, is there is this concept of continuation. So in other words, the contract fails, but you've said, no, go ahead and continue. Well, in reality, that makes the contract meaningless, because it's no longer true. You have something that has failed, but you're going to continue anything. So everything after that is now suspect. I mean, how do you, if your contract is a null pointer and you tell it to go ahead and continue, well, then what happens on the other side of that continuation is you've still got a null pointer wreaking havoc in your code.
Right.
So some of these things, and there was other places where we were introducing undefined behavior, and where I see undefined behavior, that's where I start. As somebody who likes to penetrate systems, whenever I see undefined behavior and I see somebody's using a feature that has undefined behavior in the code, that's the first place I want to attack. Because I know at some point in time they're likely to trip over that. And if I can make it go into undefined behavior, again, I can make the system go down. And that's one of the problems we run into, especially on the hardware side, is that you're talking about systems that are fairly critical, somebody's pacemaker, an airplane, things that you really don't want the hardware going into a reset on. So that's one of the reasons why things like exceptions don't get used in hardware at all. It's not just that they have overhead associated with them. It's the consequences of throwing an unhandled exception in the hardware world are pretty horrible. So with concepts, I had sort of some of these concerns of, okay, we're going to put this out there and somebody's going to go put this where they're going to use contracts to try and analyze data from an untrusted source. And we have to educate them, but then that education tends not to sort of take, and you find people in critical systems at a bank or somewhere else using this particular feature inappropriately and in the wrong spot. And then suddenly you have a breach like this, or you have something horrible happen to people. One of the things that I really liked is contracts, because I think I heard you say this on the last show, is that contracts help with correctness of a program. I like the fact that rather than me sending something in that may or may not fit what that function really wants, I like that there is a defined contract that can come in and say, this is what you have to give me in order for me to operate correctly, and that way I know as a developer what I should be sending them.
Right.
We have a couple of proposals on the horizon. I'm going to look at my list here. One is Secure Clear. So one problem we run, we've seen this quite a lot, and this is a side channel attack. I bring in a password, I unencrypt it, I use the password to log on to whatever asset that I'm trying to get to. I go in and I clear the memory, and then I go on. I think I've cleared the memory, but the compiler looks at it as, well, there's no side effects to the clear because you're not using it again. So I don't have to do the clear, and it helps me optimize your software. The problem is that is now sitting out there in memory where it can now be read using a side channel attack. So so each of the different vendors came up with their own version of a secure clear, and secure clear just sort of puts it in the language so that now we've got a platform in an independent way of, when I have some vital piece of memory that I absolutely positively need to clear, I can use secure clear to do it.
And to be clear, that's not in C++ 20. That's a proposal upcoming.
It is a proposal that we are that I like coming up in 23.
Okay.
There is the other big one that we discussed a lot here in Cologne was the zero overhead abstraction. It's zero overhead deterministic exceptions throwing values. This is Herb's.
Right.
Right.
Herb sections.
Herb sections. Yeah. It's funny
it's
how
like gore routines, right?
Yeah, it's funny how those things morph. One of the reasons why exceptions don't get used, I personally don't like exceptions, is because I see people more often they're using them for flow control. Whereas an exception should be thrown. So I was in a system the other day and they were looking at validating the data, and when a piece of data wasn't correct, they'd throw an exception. Mm-hmm. That's absolutely the worst thing you can do, simply because that's not an exceptional event. And in the hardware world, you don't have a huge amount of exceptional events. You might run out of memory, but then that's an event where you're putting the hardware into reset and starting over again. So exceptions sort of became one of those things that nobody had this really great use case for them, so everybody sort of filled in with what they thought they should do, and flow control seemed to be the easiest one. And then worst case, when I see a lot of times in code, is I'm throwing an exception out of one function, but it's not going to get caught for another 4 or 5 levels. So now you have separated the cause from the effect, and it makes it very hard to reason about how that's going to work in code. I like a lot of the things that he's got in his proposal. Yes, it's great that there's zero overhead, but one of the biggest problems we run into, and I think my bias really just comes from having come in the hardware world so often, is that unhandled exceptions are a disaster, and it winds up, we don't have a good mechanism for saying, I'm about to use a function that you could potentially throw an exception, but I'm not catching it. It's sort of up to the developer to catch that. And one of the nice things about Java is that they will fail the build if you're doing those exactly kind of things, and I don't think we've got that capability built in. I was hoping modules might give us that.
No, I mean, the original throws statements theoretically had, some basis for that, but it was unchecked and no tools, actually caught any of it, so it was removed from the language in the favor of no except, basically. It is a tooling. It's a tooling solution. It's not something that you can putting it in the language. I don't think really helps you. You have to have the tooling that does this. Right.
kind of wanted to go back to something you said about contracts, and I'm just kind of wondering what some of your thoughts are to improve the contracts proposal. I mean, you said that, it could be used to DDoS a system by, just sending some bad data that would trigger the contract. What are your thoughts on improving that?
So this is actually one of the places where I think exceptions really do excel. I mean,
Hmm.
a failed contract is an exceptional event within a system. If you've run out of memory, no matter what kind of system you've got, you pretty much are at the end of the line. You don't want it to be flow control, but this is one of those cases where you have an exceptional event that happens that now I can actually do something about it. So you throw that exception back to the calling function. Now it knows whatever it sent was incorrect. Calling terminate just sort of takes that out of my hands of being able to deal with whatever that issue was of why that function didn't like that. One of the things that I would like to see improved is I can see a use case where I may want to have part of my code with contracts turned on, but part of my code with contracts not turned on. We do that a lot with asserts. So asserts typically, when they get built into the debug versions. But the minute you push this up to Jenkins and it starts building and going out to QE, those asserts are all gone. So if you're using those for protection, they're not going to be there when the heaviest amount of testing gets done. So one of the things that I'd like to be able to do is not only have the ability to turn it off at different points, like maybe go ahead and have contracts on for the first few releases that go through the QE cycle. And then the last 2 or 3, just before I cut my release candidate, I go ahead and have those turned off. It does, the counter argument is yes, but now you're affecting how the application works because contracts are now changing, and that's fine. I'm happy doing that because I'm changing other things in the middle of a QE cycle anyway. So I'm fine doing that in a QE cycle. What I don't want is sort of this division of they're either all on or they're all off, or they're all at one level. And I think one of the things that the people wanted to change was this the idea in contracts where you either had them turned on at some build level, you had them turned up, but it was system-wide. There are some things that are very sensitive that I would definitely want contracts active through a few QA cycles, but not necessarily across the board when you start to go into a test cycle.
Makes sense. Jason, you have a question?
I'm still kind of curious, and I don't recall if you directly answered this, if you have some direct connection between C++ and security, or if you just like C++ and you like security and you like putting them together.
Well, C++ is the language I've used most in my career, going back almost 3 decades now. Security was sort of something I backed into because it wasn't something I ever intended to do.
Right.
But because you have so many critical systems that are written in C++ mainly because of its speed and its flexibility, you do have this, it sort of is the best of both worlds for me. And that was one of the reasons why I joined the standards committee was I would look at some of the decisions, especially undefined behavior. I will talk to people and they'll say, oh, well, we're going to do this, and then that's just going to be undefined behavior. And we tend to say that in sort of a cavalier manner as if, that's not the razor blades and shredded glass and the punji sticks that we run into in the language. And again, with like contracts, you can see things that potentially could become security vulnerabilities, and that becomes that was the reason why I joined the committee to begin with, was to begin. They've got several people who sort of are in that same arena, but it was I guess I'd say it's a happy confluence because I love the language. I think it's fantastic for what I do for a living. I can't think of a better language out there for it. And then, yes, most of my career has been in some way involved in security, so it sort of married both of those together because C++ is ubiquitous. It's everywhere, and that means it's going to be under daily attack from somebody on the outside. There was something interesting you said the other day. You brought this up with, I forgot which one it was, but he works for Mozilla, and he was, you said you had heard that they were moving to Rust for their backend, and he said yes, and you were talking a little bit about the interfaces, and he said Rust is the future. And And when I was listening to that, my ears kind of perked up, and I thought, yeah, and that should be really concerning to the standards committee, because one of the biggest reasons why we have Rust is because it is designed to be secure.
Right.
You can't have dangling pointers. You don't have null pointers. In other words, they've taken some of those sharp edges away, and I'm not an expert in it, so I don't know how they handle issues like undefined behavior. But it should be a concern, because we tell ourselves, and I think there's a bit of cognitive dissonance here, where we say, well, there's 5.5 million C++ developers, and there's 25 billion lines of code written in C++, so it's going to be around for a very long time. That's not necessarily true, because if someone like Mozilla is beginning to migrate away in the long-term future, as he said, is Rust, there's a reason why they're doing that. And I think at no other time in C++, I was sort of in the prehistory of C++, not the one we have now, but sort of in the prehistory.
Yeah.
And at no other time has there ever been this many options to C++ that either have the same or fairly good performance characteristics. I mean, even Java can, if you tune the garbage correctors correctly, you can get pretty good performance out of Java. And there are companies that are beginning to rewrite their back end with it. Because from a CEO's perspective, what I want to hear my CTO tell me is, this is what I'm doing to make us more secure. And the easiest button for that CTO to push is, I'm changing languages from one that the market considers insecure, whether it's truthful or not, to a more secure language called Rust. And as a CEO, that's what I want to hear.
It doesn't matter, like you said, it doesn't matter if it's true. The point is, it's market.
And from my perspective, it's free. I don't have to spend $20 million getting penetration testers to come in and do a full sweep on all of our systems. So if you're something like Saudi Aramco, you're going to spend that kind of money just getting people to go in and test all your systems. They've got something like 50,000 just desktops. That doesn't even include servers. But something like, if I were Capital One, and if they were saying, look, we've got this language in there and we've just got hit, I would want to hear my CTO say, I'm moving to something that, reasonable or not, sounds really good to a CEO.
Right.
And those decisions, those business decisions, will often overrule the technical decisions. Where, well, C++ technically might be the right decision, but if there's another option, I'm going to go with that option, even if it's not quite as good, not quite as fast, but it's considered more secure. And at no time in our history in C++ have we had this many options of things that you could actually do to get the same kind of performance curves, to get the same kind of flexibility. I think right now the only thing that keeps Rust from really sort of breaking out is the fact that it's new. It hasn't been around that long. C++, I think, turns 40 this year.
Sounds about right, yeah.
Yeah. So that's something I think the committee needs to listen to, not in a panicky mode. I'll often have people come and say, oh, you're giving the scary talk. I was like, no, if you're walking away afraid from anything that I'm saying, either I'm communicating badly or you're missing the point. This is not about fear, it's about education. It's about dealing with reality, but dealing with reality before reality deals with you.
Now that you're a part of the committee, are there any papers you're actively working on to try to help C++ become a more secure language?
So the two that I named, Secure, Clear, and Zero Head Deterministic Exceptions, I'm not working on them. They're part of the committees that I'm on. One of the things that I'm doing, the course that I'm teaching is actually the course that goes with the book that I'm writing. That is, it's going to be published through Pearson, so it'll be out sometime in the spring or summer of next year.
Oh, okay.
And it's got the same name. One of the proposals that I really liked, and it's actually something that was sort of along the way I was thinking about how the book is evolving, is it's P1705, Enumerating Core Undefined Behavior. So Jason, I know you read the standard a lot.
Oh yeah, I've actually read it cover to cover. I did that this morning before we did the interview. Yeah.
The reality is that the standard is not written for developers. It's written for compiler designers, and it's written for standard library implementers.
And some of it's almost impossible to read. If you want to understand undefined behavior around object lifetime, you have to read like 7 different sections of the standard. It's terrible.
Or you just send Richard Smith an email and he'll tell you.
Yeah, I actually pulled that trigger on Twitter the other day because I had a question I couldn't answer that my students had, and I copied him on Twitter, and I got an answer back within like 30 minutes. It was really handy.
It's fantastic, isn't it? So here's the problem. If you just restrict this to the core language, there's a lot of places where undefined behavior is very murky and at best opaque to developers in their data until they step on it. And then they don't know why things are blowing up, and then they go and they find somebody who has done that themselves. So one of the things this particular paper is doing, and one of the things that I think becomes vitally important, is there's got to be a chart, maybe a Tony table, where we deal with undefined behavior. And by the way, this is what it says in the standard. This is what it means in plain English to you as a developer. And then this is the code that will trigger that, so that they can actually see where is undefined behavior in the language that I might trip on. And I even made the mistake in a talk where I said something like, if you pop off an empty vector, then it throws. It actually doesn't throw. It's undefined behavior. But I didn't know that because it was buried deep enough in a document that I find almost incomprehensible on a good day. So that's one of the things that I think one of the papers that I really like, and one of the things that I was doing sort of for my project, is defining where are the areas of undefined behavior, what are the implications, and here's how you avoid it.
Right.
Okay. And there are a couple others. We didn't get to talk about there's another zero overhead deterministic failure paper, a unified mechanism for C and C++. What they're trying to do is they're trying to unify the C and C++ mechanisms for dealing with failure paths.
Okay.
I don't know a whole lot about it. We didn't cover it in committee, so it's probably something we'll talk about a bit later. One of the So I mentioned WG23, or it was in my bio, WG23. That is actually a group that studies vulnerabilities in programming languages. So they actually have their own sets of papers and documents that they're creating for us to be able to define where security issues are in other languages, and even languages that, like Ada, that are considered to be secure, which is why the government loves to use it in a lot of their projects. Of the 65 categories that we outline in that document, they hit 50. So they have their own. Even JavaScript has its own issues, and Java has its own issues. So there is no language that is sort of exclusively secure, and that's, I think, sort of the problem, and the reason why I think C++ sort of gets a bad rap as being an insecure language. I don't think that's true. I think there are ways that you can use it insecurely, but you can also there's a lot of freedom and a lot of capabilities in C++ that you just can't find in other languages, except possibly Rust.
Okay. Before we let you go, is there maybe one feature you think you would want to remove from C++ to help make it more secure?
You get only one.
Just one. So I can't say undefined behavior. I mean, I realize it's not a feature, but we do tend to treat undefined behavior as a feature.
I guess you could say that if you want to remove all undefined behavior, that would be tricky.
Well, when there's 300 instances of undefined behavior in C++ 17, I have to ask, do they all have to be undefined? Because those are the sharp edges of the language that people tend to run into. So if I had one thing that I could go to the committee and say, listen, if you would deal with one thing, it would really help. It would be undefined behavior, because not only is it opaque, the compilers can optimize based on undefined behavior in ways that I don't really understand. And as a developer, and I make my living as a software engineer, I teach on the side, and I write books on the side, and I do all the other stuff. It's really opaque to me as where undefined behavior can rise up and bite me, and it'll always do it at the most inopportune time. So that would be the one thing I wish we would take out of the language is undefined behavior.
There's a quote in there somewhere. Undefined behavior doesn't wait for a good time or something.
It always shows up when I don't want it to.
Okay. Well, Matt, it's been great having you on the show today. Definitely let us know when your book is out.
I will.
For sure. I did not know you were working on one. That sounds great.
Yeah. Thanks, guys, for having me on. I really had a great time.
Thanks.
Thanks.